that's S. Let me see. So I'll leave the Google Drive up with your file in case you need it for any reason. And then it's just in the downloads folder, I believe. Yeah, see right here if you need it. I'm gonna leave that up.
Okay.
But yeah, let me see about the dual display. Someone did this yesterday. I just wasn't watching. Extend. Let's see if I can get print. Yes, please. Yes, please.
Francisco's the most delightful human being. I know it's weird to have this happen for a New York State conference.
No, that's
but
fine.
I'm telling you, people in Puerto Rico now more than ever.
Yeah, I know. I think it's really fine. Okay, so that's just one. I wonder if it's because
Good morning.
Let's go.
How's everything going on? Good morning to all.
Morning. It's so good to hear your voice. It's just me and Molly right now.
hello.
Hello, Molly.
Okay, so I cannot figure out how to do the one because I think the projector can only do.
That's okay.
So like I can split the screen, but then it only does display one or display two.
That's all right. Let's see if we can just put it in presentation mode and see how he looks.
Okay.
Can you hear us okay, Francisco?
Yeah, loud and clear. And how about you?
I hear you. It sounds great to me.
Good.
Okay, so share. So he could just be like this.
Yeah, so you
Okay.
might, maybe I can make him a little bigger because I don't, yeah, maybe we,
I wonder if we just manually,
yeah, like make it, yep.
and then we could do long.
Mm-hmm.
Okay. Or I guess. Oh my gosh, sorry. Here, I don't want to. You know how to use a computer. I don't know what I'm doing.
Oh no, this is helpful. I think this is exactly why I was like not even gonna chance 9:15.
I know. Why will this not?
So Francisco, I slightly updated, teeny update on the slides.
The ones I'm working on or the rest of the presentation?
I just think that when I'm like talking in the beginning, I might just acknowledge everyone before the Mentimeter because it's sort of awkward not to. So,
Oh, yes, I think I saw that.
yeah, what we're gonna do is just like I'll just have you guys wave and say hello. Like no more than like a sentence if you feel like saying anything at that point.
Okay. That's okay.
Yeah.
So I don't know if something like this might work. We could minimize this, I think.
That could work. Let's
But
see.
obviously, like, feel free to fiddle with that. I have no preference, whatever is easier for you.
Let's see. I want to have him come out side by side. And then maybe I can spotlight him. Participants. Francisco. Spotlight for everyone. Molly. Let's see. Center layout. Yeah. So there he is. And then like this.
You didn't even at all.
And then we just need to check it again when we toggle to Mentimeter. Maybe we just leave you in the background, Francisco. But we're gonna leave you like this.
Okay. So right now I'm looking at the presentation and Molly shows screen or
Yeah.
camera.
Yeah.
So people are going to be looking at me and the presentation.
Yes. People
Okay.
like you. There is a camera in the room, but I don't think it's really worth
No, that's
worth
okay.
it unless,
Yeah.
Yeah.
You can give it a try, whatever.
why not?
Um. Okay, yeah, so I don't know
Oh.
if it changes his.
That's weird. Can you see me?
No.
Okay, so doesn't need to be the case. What did I just click?
So you'll go back to PC.
Okay.
You could turn the camera on here possibly, and that might link.
I,
If
I-
you want him to be able to see you.
I think, Francisco, are you okay with just hearing my voice?
Yeah, I'm okay.
Right. Yeah.
Actually, I would prefer not to look at the audience because I get distracted.
That's just pretend like you see us. I'm just gonna practice toggling to the Mentimeter quickly to make sure I can do it with some.
I'm gonna write that myself. I have to go get the other session going
Okay,
and gateway.
perfect. Is this browser? Which browser am I on?
I think you're on the second.
This one?
Um,
This one. Yeah. Mentimeter. Okay. All right, Francisco. Oh, he's staying spotlighted. Perfect.
Okay. So my cell's right here. If you need anything, I'll be over in gateway, but I can make it back in a few minutes.
Okay. Thank you so much.
You'll do great.
This is gonna work.
Thank
Francisco.
you.
Thank you. Bye.
Bye. Francisco, do you want to see the Mentimeter quickly?
Yeah, let's do it.
So we have this beautiful picture of you and Susan
Oh,
setting
I
the
see.
stage. How well do you know your small water systems? In a few words, where does your water come from? And you can chime in on this too. Don't be scared to chime in and add like commentary. What best describes your role in water? Do you represent? I don't think we're going to get many people that do, but we'll ask. And then this is like a quiz. Which of these could be a public water system? Do you think that
Okay.
this is like going to be fun and surprising?
Which of these could be a public water system? I don't. I see a building on the left. Then I see a sink, water bottles, and the second one from left to right. I cannot see what it is. I guess it's a water treatment plant.
Oh,
Or
you
not?
can't see it?
I
It's
see it, but it's very small. Just the second picture from left to right. I
yeah.
cannot see the details of the picture. I just see a road, like a building on the back.
Okay, it's an apartment complex, a rural campground, private home with a well, and a bottled water plant. It's showing up here. It is a little small, but I'll read it out.
Mhm.
That way I know to read it out. But
Okay.
it's sort of like a trick question because a bottled water plant is not technically a public water system, you know?
Mm-hmm.
They're regulated as packaged food.
Mm-hmm.
So then do you think people will be surprised?
Yeah, it's good because you're not showing the obvious, so it's good for
Yeah.
people to think about it.
You think it'll be fun? Like a
Yeah.
little like Jeopardy quiz type thing?
Mm-hmm. Yeah.
Okay. Then we have according to EPA, a public water system provides water. This is the definition. I feel like lots of people don't actually know the definition, so that could be fun.
Mm-hmm.
And then I have a few. Oh no, you disappeared. Was
Oh,
that
because I click on the on the video, so I can appear back. Hello.
I'm just scared it's you can go off camera if you want.
Okay.
Um yeah, then we have, so this is a small water system in the Adirondacks. That's a campground. They have like one spigot, but they're technically regulated. Then here's one in Cato, New York.
Mm-hmm.
Not that different from Puerto Rico.
Mm-hmm.
Then this is a general store in the Catskills. That's a small water system with a well.
Oh, I know a farm that is a never sink, a very well-known farm in the small farming world.
Yes.
Yeah.
Izumi is here, Francisco.
Hey, Zumi.
You see me?
What's up? I don't see you, but I guess you see me.
He
I'm
can't.
just trusting your voice.
Yeah.
It's me, I'm wrong.
You can just pretend everyone's in their underwear.
Yeah.
Okay, so then we're gonna do there are approximately 148,000. Oh, Azumi, I have a question for you. Ruth was scared that she had to present the project. But she's not doing that.
No, no,
That's
no.
fine. She's just doing the SD. and
Yeah,
then-
just that. Yeah.
Yeah.
And then it would be to you, because I think all I slide is the website.
Yeah, I have like 3 after the website that I'll do. Yeah. Confirmed. We are all here.
So it's just Tess, you, I mean, yeah, you, Izumi, and Ruth.
Yes.
Okay, is there's gonna be anyone in the audience from our team?
Yeah. A bunch of people are coming from the team. I
Okay.
thought Carly was coming, but I'm not sure anymore.
Okay.
We're gonna get I think Avery and Jess will be here. We invited a bunch of folks from ECS. Oh, good idea, Zoomy. Yeah, I can maybe set them out somewhere. 95. Yeah, I have no idea. Francisco, do you think this is a fun question? Are you surprised
see.
that there are so many small water systems?
Yeah, yeah. As you said, not many people know about small water system, so it's a good thing to have and to get people thinking about it. And that
Right.
way, when I start talking about small water systems in Puerto Rico, they have a better picture of what we're going to be talking about.
Yeah. Izumi, I added this. True or false? 46 out of 62. Yay! Hi! Hello. Jess is here, Francisco. Jess
Hi,
Epry.
Jess. Hi.
I just hung up with Winnie. I told her I was so excited for your presentation.
You guys can see me, but I can't see you.
That's right. So
Was
what
that
we
the
hear?
Tioga call?
Yeah.
Okay, is that going okay?
It was kind of funny because.
Because I have met with Tioga before on their 2023.
Oh, okay.
Yeah.
All of their questions were extremely specific to, how much information on the timesheet, just as a supporting document for the SM 270, and Winnie didn't know any of the answers. Maddie is brand new. So we didn't have any answers for them, but we'll figure it out together.
Francisco, can you chime in on this question after people click the answer?
No, you do it. You do it. You're gonna be good with it.
I just know the correct answer is 1 million.
I think so. Yeah.
Yeah.
Actually, I think maybe do a quick Googles. I mean, or just leave it like that.
I
It should be very close because I believe that number changed and now Orlando has more people, but New York State used to be the largest population. But just keep it around that. It doesn't have to be perfect.
Hi. Hello.
Oh, monochromatic almost.
Francisco, Ruth is here.
Hi, Ruth.
Can't really see us.
Yes.
But he can hear
Cool.
us.
Like, can you see the audience or he doesn't have any video?
They didn't, just if you keep going straight down the hallway, almost to where you see the Yon Lab sign, you have to basically go to where you see the staircase, and then
Okay.
it's on the right. Yeah,
Cool, thank you, I'll be right back.
you're welcome. Okay. You don't have anything you want to chime in and be like, by the way, Puerto Rico, blah, blah, blah?
I don't know. What were you thinking?
I was thinking something like,
Well, I can
more
say,
people that don't live in Puerto Rico than do now. Like now there's more Puerto Ricans outside of Puerto Rico than there are on the island. I don't know if that's true. I think Kyra said that, but now I don't know if that's true.
yeah, at least people that identify as Puerto Rico in the census, there's more in the
Yeah.
US, close to or maybe more than 4 million. We only have 3.2 here now. But I can say I can add that federal safety or the federal compliance regulations for drinking water, like the Safe Drinking Water Act, also applies to Puerto Rico. That may be a fact that not a lot of people are aware of. And
Okay, I also added this one.
it's too small to read. Can you read
Too
it for me?
small? Can you see that?
Let's see. True or false? Both New York State and Puerto Rico rely on.
I'm gonna see if I can make it bigger. And
Okay.
here is,
Make it on a couple of lines. Saying. Yeah.
There. It's better.
okay. All right. Yeah, and then maybe you could chime in and remind people about Nueva York. Nueva York, Bad Bunny.
Actually a concert.
And just reinforce, just reinforce that like New York and Puerto Rico
Mhm.
have a thing going on.
Yeah.
Yeah.
Okay. That's good.
And then we have a few questions about wastewater. Okay, oh, so this is new for you guys. So for the collaborative session at the end, these are the questions. So it'll be thinking like a water system, collaborative problem solving is what we're calling it. We're going to ask people, how can we better support small systems in New York State? And then people are going to reply, and then they can actually plus up or vote on things. And we can see what ideas people like, and we can call on them to like explain or expand on anything. And then we'll see the results. I have like, what would effective collaboration look like for small water systems in New York?
We just make all, like, whenever it's a small font.
Yeah. Yep.
I don't imagine this is big for it, but
We can
that one.
make them not. Yeah.
Yes, I'll be back in 1 minute.
Okay. Jess, can you see this text?
Yes,
Okay.
it is older person friendly, yeah, thank you.
Actually, I shouldn't too. Or did you want to show me any more?
I think this question, what would effective collaboration look like for small water systems, sounds like we're talking about the systems. So maybe like for solving these challenges.
Oh, like between, it's not
Yeah.
between systems,
Yeah.
it's like between.
I'm just gonna say these challenges.
Mhm. Yeah.
Okay, Jess, we're gonna need you, if there's like not much participation,
All in.
yeah, I'm gonna need you to like use the Mentimeter, put in like 15 things.
There was an excellent question in the panel, Avery's panel yesterday. Simple, but what does success look like to you? And oh my gosh, Ted, like.
Yeah.
After school special, beautiful. It just-
Yeah.
Got me in the feels. Yeah.
I think what's hard is I'm not sure how much people will know about small systems.
True.
So. Oh,
You're right.
I'm
I
sorry.
met yesterday, I'm Jeff, yes, okay, in passing. Yeah, I thought I met you yesterday. You have a doppelganger. I do, I should tell him that.
Hello. Okay, put it back on our. I can't swap it.
I'm back. Can you hear me, Tess?
I can hear you.
Okay, great.
We're getting started in a couple minutes.
Okay, I'm gonna
How
be
was breakfast?
what's
Good.
that?
Oh, we have a few folks that have trickled into the room, so I'm asking how the
Okay. Okay.
You were great breakfast, Brandon.
I bet his breakfast was nice and fresh,
probably.
a fresh breakfast in Puerto Rico.
Mhm. I don't, but you know what? There's a solid 50-50% chance Jess has a Band-Aid.
Do you happen to have a band?
Every now and
I
then.
feel like I just.
She's a mother.
Man, I feel like that's okay, it's such a small little wound. And
Do you have a tissue?
I've got it, yep,
I
as
have,
long as people are not distracted.
no, you guys say I have a sticker, we can make it that big.
That's the spirit.
Yeah.
I'm gonna,
Sticker and a future water leader.
Oh, it's like a MacGyver.
Yeah,
Yeah.
oh, that's not what I want.
I have to bounce right at 11:30 to jump on a call, I don't think I'm storming out.
I won't think that. Okay. See if this. Works. Does not work. Never mind. Never mind.
Oh, okay, good. Yeah, the, main session's going long, so, that.
All right, I messed with things. Now I gotta make it go away, go away. Um,
Oh. Looks like, yeah, the secondary screens switched to it, you know what I mean?
yeah. I just want to duplicate the slides, duplicate. Keep changes. Okay.
That's kind of funny, none of us can answer any of the questions.
Yeah.
There are two people from UVA. Well, because they're, this items, there's like a procurement specialist who does all the, who's want to drive on top. The, contract. Yeah. Just didn't know there were people.
Oh,
I
no.
think that was kind of good for Carla to do, that one has to call me and we want to.
Even the people who seem like they should have the answers. It's supposed to be like a teal.
I think it's this black that this match.
Okay.
Oh, I see. There's a screen down here.
Yeah, I think, all right, so this, I was trying to get presenter view, but you're not gonna get presenter view.
Well, print it out my.
Was it last June? Riley's training?
Is CD.
Yeah.
Nope.
Yeah, so.
Yeah, okay, so it's in there.
No,
It's gotta be one. Oh, cause it came out of.
nah, there's no way.
There's
It's too
no
late.
way.
It's too late.
Like maybe these are just mirrored and.
I tried extending them and I couldn't get it, and now it's 9:31, so I think we're gonna not
Yeah,
mess with it.
I think they said welcome that they were running a little behind.
That's good for us. Good for us, I think. Okay, Ruth, so we have our workshop questions. Okay. Workshop questions are gonna be, how can we better support small water
Mhm.
systems in New York State? What would effective collaboration look like for solving these challenges? And what's one thing about your water that keeps you up at night? Just a little bit more broad.
Okay, cool. I mean, those are all good. That second one's meaty. We'll have to give them time.
Yeah.
It's good. We don't, I only have 2 hours.
I
Although
know.
maybe we have less than 2 hours now and we can skip that question. But you know,
I think it's a good one. I think it's better than us. I mean, I could talk low, I could talk less if we need the time. You know what I mean? Like, if we could,
I know
Yeah.
exactly what.
yeah. And these are off the bat, right? So.
These are off the bat, so
I can pick it.
yeah, they're all at the end. And if so here's where we landed on our, so I got a few more, to make it more New York-y.
Mhm.
I have
Mhm.
3 pictures of New York small
Mhm.
systems. Johns Brook Lodge,
Mhm.
which is a surface water transient system. Cato, New York, which is just a 40-foot groundwater well. And the Never Sink gas station, which is a well as well. And then we will have a question about the percentage of systems, but I've added that in New York State that there's only a total of 8,000 systems and only 156 of them serve large communities,
Mhm.
which is crazy. We have this. Are you surprised? We talked about that one. Small water systems are more like, why do we think this is? And this is a way for all of us to chime in and be like, well, have you thought about this? Or like, have you foreseen that? That's our experience. True or false? In New York State, 46 out of 62 counties are considered non-metropolitan, because I think it's like 86% of the land area is considered rural.
Yep.
Talked about where water comes from in a few words. Where does your water go after you use it? And then after people talk about that, because most people will go into the sewer here, but as you know, there's 8,000 systems. How many publicly operated treatment works do you think we have here in New York? 691 is the correct answer. Wouldn't let me make it a number. So we'll see where people land on that, and then we'll hit them with well, actually, there's 22% of homes are on septic, so it doesn't quite line up the way water does, and then you're set up to talk about your thing. And then we get to 2 Puerto Rico questions. And Francisco will chime in about Bad Bunny.
That's for test plans.
Do we want to add some commas in here
Where?
for the, just so it is consistent? And then
Yes.
people don't have to count the zeros.
Thank you, my detail. Thank you, my engineers.
That's all. I only care about this number.
Detail oriented engineer. I am also an engineer and I did just gloss, right?
You have no idea
Yeah.
how needed you are.
Agreed.
And then we have a true false.
Just, I guess.
Both New York State and Puerto Rico rely on surface water for the majority of their public water supply, which is true.
Is it?
It is true.
By people.
By people.
Okay,
Yeah.
and I see
So I feel like, I feel like we had like a few questions that more point to like number of systems, and then a few questions that point to the population.
Yeah.
And like people might make
Number of people,
assumptions,
yeah.
based on population about the systems, but that's not
catch.
necessarily true.
Good catch.
Yeah.
There we go.
All right. You have some, that's so cool.
We're gonna,
Oh, good. But that actually.
Would you mind if you just, let me just like can we just scroll through just to know the lineup? Because our transitions are.
I know.
Yeah, I'm gonna be like, and
Okay,
yes, and
test,
it's gonna be like,
test.
believe me.
Tess, I did bump this up just to like acknowledge you guys before the Mentimeter, and
Mhm.
you can either wave or say hello, or whatever works. There's when we go Mentimeter, we come back, it's Francisco.
Yep.
Francisco.
You can just scroll. Okay. You
Yeah.
just try some. Yeah. Okay, then it's me just, so I'm just gonna let you know also, I'm doing just my basic intro. Two pieces that really came together, and then I actually brought this in.
That will help.
And this is outdated because I do talk about later the updated numbers, but I just want to kind of, maybe I'll even just skip that one. And then I'll end with just this one, talking about the built-in places.
Because I
And
have
then
the number 2.
go into you.
We could always just send it out.
Then that's your transition slide right there. So that's
Okay.
just, you hit that and that's, you just move right along, but
Okay,
that's just so you know that,
just gonna scooch by.
yeah.
And then I did added a couple things about the curriculum. Come back to that. And then I even am I have these in here, but I know you're gonna talk about them later, so I'm just gonna go over them briefly, and then I'm gonna do that
You.
for them later. Yeah,
Yeah.
that's fine. I'll come
So
back
you
to it
can- you can
and
decide what you
pick
want
up what I
on.
bring. Yeah. And then I did put this in here to bring it back. I know you're gonna talk about that later, but I wanted to talk about our
No, you talk
impact.
talk
Okay,
however,
cool.
yeah. And then this
This
is
is easy. Okay,
Yeah.
great. Yeah. And you know what's in here. Did you want to change?
Yeah.
Talk to the moderator about that.
What do you want?
Wait, just, there's this one. We can just change it now. We can just change it right now. Oh, no. Oh, I see. 26, okay. Maybe plants. Cool.
Right, yeah.
Okay, it's frozen. Yeah, I was gonna ask you where you want us.
Yeah, stay under here, something the juice. Yeah. Yeah, I didn't realize that the river consortium when they go to that. Yeah, I was they were all put out there. Oh, saying, yeah, because I didn't realize like. Houses, I was we studied this as yeah. But it's clothing, yeah, but it's not, yeah, yeah. Building company, I realized that's what. Still, probably because some. Yeah, I agree. I know, like. There is. Sure, like sound. And I think I actually say that's the and yeah. Oh, yeah. I would be a bit or something. I think you're working. It's actually I was. I really do give 2 more minutes. Sitting with something. Oh yeah, it's like this has her. Yeah, it's actually. Then I'm gonna. Yeah, and I could hear it. Yes, yeah, and I'll read, right, I'll read you. So we don't say it in here, it's not read it, but it's not. So I have to color this all. Are you going to be here? He's like, I can't understand. I was pretty sure. Okay, so that's what I have like that.
Oh, a clicker.
Yeah, that makes sense. I don't know what you call it. So I just updated that one actually. Still in three times. Yeah.
I think I'm gonna do it. Oh, one more. Hi, everyone. I think we're going to get started. So as not to waste your precious time, I hope everyone enjoyed breakfast. How was breakfast? Good? Okay. So welcome to a session that we're calling VersaWater, Addressing Small Water System Challenges in New York State. We're calling this a collaborative learning session. My name is Tess. I've presented before at this conference, so I feel like we're all friends and like I know everyone here. But we'll get into a little bit of introductions in just a few minutes. First, I wanted to just let you know what to expect with this session. So we were all maybe here yesterday. We've listened to some incredible presentations. Our brains are full of knowledge. Since we're 4B, what we wanted to do was make this a little bit more workshop-y, a little bit more interactive. So you will be asked to participate. So phones out are a good thing. We're going to be using Mentimeter. Raise of hands if you've used Mentimeter before. Okay, so Mentimeter is an interactive polling type of platform. So please, if you can, use your phone. If you are not comfortable doing that, just use your hand, raise your hand, contribute however you'd like, or jot your notes down, and we could even collect them from you at the end.
There'll be a QR code.
There will be a QR code when we get to that part. So you'll be able to easily access the Mentimeter. So first we'll be doing a warm-up on Mentimeter that we're calling How Well Do You Know Your Water Systems? As I mentioned, this is a session about pumps and pipes. We're really talking about infrastructure in this session. Healthy water solutions means all kinds of water. And this is a session where we get to talk a little bit about what that infrastructure looks like. So we'll be warming up with how well do you know your systems. Then we're going to talk a little bit about Puerto Rico. For those of you that don't know, Puerto Rico has quite a lot in common with New York. So we'll be learning from Francisco Guzman, whose face may appear on the screen shortly. There he is. Okay. So we'll be learning from and with Puerto Rico. Then we'll launch into some organizational introductions. You'll hear a little bit about the group of folks working on the VersaWater project. We'll talk about our convergent research approach. And then we will do another sort of workshop-y activity that we're calling Thinking Like a Water System, Collaborative Problem Solving. So that's going to take us through to the end of our 2-hour session together. We've set this up to be pretty flexible, so don't feel intimidated. Raise your hand. We're flexible, so we can adjust our timing to have conversation and to work together on some of these solutions. Okay, so just acknowledging who's here with me today in the room. I have Ruth Richardson. Ruth is the PI for the VersaWater project, and she's with Cornell University. And then I have Azumi Matsuda. Azumi is with Agua Clara Reach, which is an international but New York-based nonprofit. And then inside the computer, hint, hint, turn the camera on, is Francisco Guzman. And Francisco works with me at Syracuse University, where we work across EPA Region 2, which is New York, New Jersey, Puerto Rico, and the US Virgin Islands. So Puerto Rico is in our region, and Francisco is joining us from across the Atlantic Ocean. Sorry. Okay. So from here, I'm going to ask you to please pull out your phones. we're going to do how well do you know your systems? This is a little bit like trivia, so I hope it's fun. Yes, I can. And I can actually make it a lot easier by going. This might even be easier. Oh, sorry. Let me go back. Go here. All right.
Question that comes up is what would effective collaboration look like for solving the challenge in New York?
That doesn't sound right, but we're going to start the presentation, so hopefully it will make it better. Okay. And if folks are not on there, you can also just type menti.com and put in the code, which will be up the whole time. Okay, so first, in a few words, where does your water come from? And if folks aren't using Mentimeter, you're welcome to just share that out loud with the group too. Well, drinking water. Let's say drinking water. Okay, so I'm seeing Skinny Atlas Lake. Syracuse is very proud of our water, so I'm not surprised to see that a lot of folks are saying exactly which surface water source we're seeing it from. We have lakes, water treatment plants, Lake Ontario, vending machine, Otisco Lake, my well. This is a really knowledgeable group and not surprising that a group at the Healthy Water Solutions Conference feels connected to where their water comes from. But this is great, and it helps us ground ourselves in where our water is coming from and how it maybe gets to us here at the conference and elsewhere where we consume our water. Okay, what best describes your role in water? This is just selfishly, we like to know who's joining us in the room, but it does help us. And if you're more than one of those things, just pick your favorite. It's definitely okay. We all contain multitudes. Okay, so I'm seeing lots of learners, students, community members, several industry professionals. That's wonderful. Would anybody like to say a little bit about themselves and where they're joining from? Yes, Micron. Okay, industry professional here with us in the space. Okay. Do you represent a water system? This is a long shot, but we always like to know. And in our work, we do a lot of work with water systems. So whenever we know that there is one joining us in the room, we like to really know and see them and hear them. So, okay, no water systems, but that's okay. There's still a lot to learn about small systems. And especially this is a group that's well positioned to support the systems that we have here in the state. And so it's exciting to be doing that together. Okay, this is a little bit of a trivia. Which of these could be a public water system? And if this looks a little small, I'll read it out. So on the far left, we have an apartment complex. And we have a rural campground. We have a private home with a well. And we have a bottled water plant. And we're looking at a public water system that's defined by the EPA, for example, or the Environmental Protection Agency. Okay. All right, so some folks and you can select more than one. So you're seeing that a lot of folks are identifying that apartment complexes can be systems, campgrounds, bottled water plant, and then some folks are thinking a private home with a well could be a public water system. So interestingly, all of these maybe could be correct because definitions are wonky and strange and weird and work in all kinds of ways. But if you're looking at an EPA definition in terms of what they consider a public water system, there's a couple different kinds of systems. Private homes with wells are not regulated. you're just on your own if you have a well. Nobody is looking out for you, and you are taking care of your own system and managing it however you want. Bottled water plants, interestingly, not managed by the EPA, they are considered packaged food. So the FDA regulates bottled water plants. Maybe there's a case where that bottled water plant actually has pipes and conveyances and tap water, and they are both. But in general, bottled water actually a little bit regulated less stringently often than some of our public water sources. And so apartment complexes, they might be a water system, because according to the EPA, a public water system provides water for human consumption through pipes and conveyances to at least 15 connections, or an average of 25 people for at least 60 days a year. And it doesn't matter whether it's publicly or privately owned. It just matters how many people you're serving and how long you're serving them for. So that is how EPA defines a public water system. Sometimes it's a little tricky because, hey, I'm going to buy a campground, or hey, I'm going to buy a gas station. That might, depending on how your water arrives at your gas station, might mean that you're a water system. Sometimes we meet folks in our line of work that don't know that they're water systems. It has happened. Small water systems typically serve under 10,000 people, just as an aside. Okay, so is anyone familiar with this place? Yeah, so this is Johns Brook Lodge, and Johns Brook Lodge is a regulated small water system here in New York State. They have, I think, one spigot, and it provides drinking water for like 6 months out of the year to folks that go to the Adirondack Mountain Club to recreate and to stay. And so they are a small water system. They have to test that water, and I believe it's surface water, and they actually have to ensure that it meets EPA drinking water standards, and they do. So this is a small water system. This is Cato, New York. It's a well, the 40-foot well with a pump house around it. And this is a water system. It doesn't look like a water system. Anybody can kind of walk around it. They do have a fence up, which is great for security purposes. And this is a water system. This is the Neversink General Store in Neversink, New York. So they also have a well, and they serve their water through pipes and conveyances. And so they are regulated as a water system. There are approximately 148,000 public water systems in the United States. About what percent of them serve 10,000 people or fewer? Here you can put in a number on your Mentimeter, and you got to guess. So we have some guesses in the 80% range, the 20% range, the 60% range. Couple more in the 60 to 70%. All right. Lots of folks, lots of guesses. This is my favorite kind of trivia question where they make you guess a number. So I really enjoy it. For folks just joining us, we're doing a Mentimeter. So you can take out your phone and you can go to menti.com here on the left side of the screen and join us. Okay, so it's 95%. 95% of systems, 95% of systems in the United States are small. They serve fewer than 10,000 people. And of those 95%, the bulk of them are even smaller than 10,000. A lot of them are actually in the under 500 people range. These systems serve a relatively small share of the population. That's probably not surprising, right? There's a lot of systems that serve a few people, and there's a few systems that serve a lot of people. So most people get their water from large systems. 80% of the population nationally gets their water from a system that serves a large number of people. But that still means there's a lot of small systems out there that have the same responsibilities. In New York State, there are about 8,000 systems, and only 156 of these systems serve large communities. So that's, again, over 90%. And then nationally, 30 million Americans are obtaining their water from these small systems and very small systems. Are you surprised? Are you surprised that there are so many small water systems? Yes. Why are there so many small water systems, you might ask? I was not aware of these systems of these numbers, but I'm not surprised. And I am familiar with small water systems, so I am not surprised. Thank you for all putting your little bubbles in. I'm impressed that some of you are this familiar. These numbers shocked me when I joined this field. They still kind of astound me, to be honest with you. So can I pick on somebody who's surprised? Why do you find that so surprising? Anybody? Yeah. 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 There's so many systems, and they're transient systems. They're gas stations, and yet they're complying with federal regulations, the same ones that Onondaga County Water Authority has to meet most of the time. Maybe slightly different, but a lot of them are the same. Can I pick on anybody else? Ruth?
No, I'd rather hear from people. I guess maybe it's a good time to add, I'm not sure if any of us are gonna talk about it. What was shocking as we've been learning together is, like I have a well at my house, and when I bought my house, I had to show that the well was clean, and then I can move in, and I don't really think about my well again. And as long as the electricity's on, I got my well, and I don't have to monitor at all. As soon as you hook that well up, or surface water system up to 15 households or 25 people, the things that kick in for you become a small water system. And the list of regulations and standards and everything is just jaw dropping. And I think that's sort of the meat of it for us, is like that. Once you get into this small community, it's not just you have to produce more water with less resources, is you have to do all this capacity. You have to understand the regulations. You have to, like money, you have to know what to charge. You have to do something if your neighbor doesn't even pay, that kind of thing.
Yep.
So I thought maybe that was a chance to emphasize that.
Yeah.
There's that jump that happens.
It is a jump, and it's a good jump. We want our systems to create and provide safe drinking water. That's why these regulations exist, but it doesn't mean that it's easy. Providing safe drinking water is not easy. It's very hard. And when you're a small system, as Ruth said, like you're making a big jump. Imagine that, you're an apartment and you add one more connection, you can easily find yourself overwhelmed with the amount of regulation, maintenance, operations that you have to do. Okay. Small water systems are more likely than large water systems to receive public health violations. Why do we think that is? And it is a meaty question. So we can take a few minutes to kind of think it over. It comes down to providing safe drinking water is very hard. Large systems, it's not easy for them either, but there are reasons for this disparity that I think a few of you are already well on your way to identifying. So yeah, these are right on the money. Less resources, fewer resources. That's exactly what the research has shown over and over again. Few staff, less capacity, harder to access federal and state money, smaller budgets, less experience. Resources. So, I mean, that is the meat of it. So there's some nuance occasionally that you can get into, such as, rate bases being smaller, so you can collect less money. And then you have, a diseconomy of scale. When you have 1,000 people, sometimes you can use similar equipment, you just bigger amounts of water. Some of those costs are fixed. So small systems have a greater share of cost for the amount of people that they have to serve. All those things are true, and all of those things make it difficult to serve and provide safe, clean water. Awesome. Okay, we're not done yet. True or false? In New York State, 46 out of 62 counties are considered non-metropolitan by USDA. True or false? We're all New Yorkers here. Yes. Okay. No surprises, that is true. Most people that live here have kind of observed this, but we are a state that has 86% of our land area is considered rural. And then we have these massive population centers that take up relatively a small amount of land. And we have people spread way far out across that massive land area. And those people are reliant, for the most part, on smaller water systems. So it's a lot of space in our state, relatively less people, but those people still need safe, clean water. We talked about where water comes from. In a few words, where does your water go after you use it? And would anybody care to share a little bit about where they know their water goes? I know everybody here is well connected to their water. Anybody like to share, hey, my water goes here? Brilliant. Yes.
Syracuse,
Yep. Wastewater treatment plant. So we have some sewer, treatment plant, groundwater, ocean, Onondaga Lake, wastewater streams. Francisco's in the way.
Traveling. Francisco's traveling.
He's traveling. If I minimize him, it's going to be too hard to get him back.
I'm good.
Okay. Wastewater treatment plant, then back to the river. So this is a group that's well connected to where their water is coming and going from, which we expected. But it's really helpful, again, to sort of ground where we are with it. And again, when we zoom out and we think about this infrastructure at scale, a lot of it is going to treatment plants. And in EPA land, we call it POTWs, which is publicly operated treatment works. And as you know, there's 8,000 small water systems. How many treatment works do you think there might be in New York State? Plants like Syracuse Metro, where the water goes and it's treated and then returned. So I'm going to ask you whether it's 1 to 500, 500 to 900, or over 900. So looks like we have some folks, a lot of buckets in the 100 to 500 range, couple bubbles in the 5 to 900, and then a few folks in the over 900 range. The correct answer is 691. There are 691 POTWs that are publicly operated. There are 8,000 public water systems. Why is this? There's a lot more water systems than there are wastewater systems. Well, no surprises to this group because I see Carol here and I see several others that engage in our septic work, but that's because we are a state that really relies on decentralized treatment. And 22% of homes in New York actually have their own decentralized treatment unit, which is typically a septic system. Anybody here have a septic system? Yep. So the 1 in 5 holds true in this room. Yep.
Can I ask how many of you don't honestly know where your wastewater, where your wastewater goes? Very well educated audience then.
Yes. This audience is connected to water. But this is not quite the same, pattern that we see infrastructure-wise. These are slightly different infrastructure. But what does converge here is the challenges. So at the small scale, you're starting to see at the homeowner level, some of these same challenges stack up because managing a septic system comes with a lot of the same challenges. You're regulated from a public health standard by your county or by your town, depending on where your local laws are. And you have, you're responsible for managing a public resource, which is water, on a private system, which is very tough. So we start to see these challenges begin to stack in strange and interesting ways. And that is kind of why our group has been interested in that small community level of water infrastructure and the problems that kind of converge there. Bonus question, because we're going to talk about Puerto Rico. How many Puerto Ricans live in New York State? Okay, everybody. Okay, starting to see some variety here. All right. Okay, correct answer. We're going to move along. 1 million. 1 million Puerto Ricans in New York State. There are only 3 million Puerto Ricans in Puerto Rico. Francisco, is that right?
3.2 million Puerto Ricans in the island and about 4 million in the US, or people that identify as Puerto Ricans in the US. But there's a very large population in New York. New York right now is competing with the state of Florida with the largest Puerto Rican population. But definitely there is a connection between Puerto Rico and New York. When I say to people that I work within Region 2, and Region 2 includes New York and New Jersey, people ask why, and I guess it's because of the Puerto Rico-New York connection.
Yes. So we have this link to Puerto Rico. We share some of the challenges. One of those challenges, I'm going to ask you guys, true or false? Both New York State and Puerto Rico rely on surface water for the majority of their public water supply in terms of population. You guys are too smart for my true or false questions. Yes, so we're both very water heavy. We're very wet areas of the world. Puerto Rico and New York, lots of rainfall. Syracuse, a lot of rainfall. Puerto Rico, a lot of rainfall. Some of us might wish that it was that tropical, wonderful rainfall that you get in Puerto Rico with the beautiful flowers and the cookies and the frogs, but we have a lot of water in common. And that means that a lot of our water that we're drinking is coming from surface water sources. So Puerto Rico, similar to New York, big population centers, big swaths of rural area. We have small systems in Puerto Rico. We have small systems in New York. Those small systems are facing some of the same challenges in different ways that we're going to talk about today. Okay, and from here, I'm going to toggle back to our presentation. How do we feel? Do we feel warmed up? Warmed up? Okay. So from here, I want to hand it off to my colleague, Francisco. We wanted to start this session with a little bit of information about why Puerto Rico's systems are struggling in the ways that they are, and have you guys think a little bit about that and compared to what you see here in New York. So we're going to start with learning from Puerto Rico, and from there, we'll tell you a little bit about our VersaWater project and why we're excited. Okay, Francisco, over to you.
Thank you very much, Tess. Good morning, everyone, officially. As you know, my name is Francisco Guzman. It is a pleasure for me to participate in the Healthy Waters Conference today, and thanks to the organizers for allowing me to join you virtually. And to start my intervention, the first thing I would like you to do is to take a look at these pictures, portraying some of the things that happen during the aftermath of a storm or a hurricane in our case. As you can see, light poles go down, the power outages happen, muddy or turbid waters appear on surface water bodies, and both scenarios directly impact the ability to provide drinking water because we need electricity to treat water most of the time. Similar as Tess had mentioned, similar to small systems in the US, Puerto Rico systems frequently deal with limited technical expertise, aging infrastructure, financial constraints, and this make it harder to comply with EPA standards and the Safe Drinking Water Act. So locally, recent natural disasters have aggravated these difficulties. As some of you may know, Hurricane Maria impacted the island in 2017. Next year is the 10th anniversary, and we are still struggling with the aftermath and the disaster that occurred after the hurricane, and we are still rebuilding after that. Some of the primary factors that lead to water shortages include frequent droughts, extreme precipitation, flash floods, landslide, earthquakes, and hurricanes. And furthermore, Puerto Rico is undergoing economic constraints that have placed additional burden on these systems, particularly the small water systems, and which limit access to funding and resources for the necessary improvements in infrastructure. Next slide, please. Okay, so why Puerto Rico? Well, small water system, as I mentioned here, face additional confluence of challenges, right? So let's start talking about frequent storm hazards. The island faces severe climate change risk, including extreme heat, rising sea levels, catastrophic hurricanes, threats, as I mentioned. And these hazards can endanger 32% of the critical infrastructure and threaten the island up to 379 billion in economic damages by 2050 if mitigation and adaptation efforts are not rapidly scaled. The other challenge is unstable electricity. Puerto Rico's power grid remains highly unstable. It's an old, fragile infrastructure, relies on outmoded fossil fuel plants, very old plants built back in the early 60s. And delays in long-term storm reconstruction have created an emergency level crisis. Power outages now is a common thing. So don't be surprised if suddenly I disappear. Probably it's a power outage. Also, and very importantly, the high poverty rate. The poverty rate in the island is about 40% of the population, according to the U.S. Census data. This is significantly exceeds the mainland U.S. national average of poverty rate, which is roughly 12.5%. So the difference is significant. The map you see on the slide illustrate how small water systems are primarily concentrated across the island, particularly in the central mountainous regions. So those red dots represent small water systems across the island. Next slide, please. So let's talk a little bit about non-plazas, which are the small water system. But first, let's begin with some general concepts about water, starting with the Puerto Rico Aqueduct and Sewer Authority, or PRASA. PRASA is a public corporation and is an instrumentality of the government. PRASA owns and operates Puerto Rico's public water supply and wastewater systems. It provides drinking water to close to 97% of the population and 59% in terms of wastewater services. PRASA operates a very complex system or infrastructure and is considered one of the largest water utilities in the US, operating more than 50 water treatment plants, thousands of kilometers of piping. So it's very complicated. So going back to the 97% of the population that gets drinking water from PRASA, what happens to the rest of the 3% of the population, which represents about 94,000 individuals that rely on community-operated drinking water systems, which are called non-PRASA, meaning that they are not part of the centralized water systems PRASA operates. This small system primarily serve small rural communities across the island, as you saw in the map. They often face challenges related to water quality, long-term sustainability, and so on. On average, these small systems serves 400 people, with the smallest systems being 25 individuals and the largest up to 2,500 people. So they can be considered very small water systems, actually. Among the 235 to 240 registered non-PRASA systems, 60% rely on groundwater, 39% on surface water, and there's a 1% that has both sources, meaning some of the water they get it from groundwater and some of the water they get it from surface water. and notably 23% face daily water shortages. Next slide, please. So there's a big problem or big challenges for these small water systems, and these systems are not faced by large cities or large towns that have more bold systems that have more resources, as you recognized during the Mentimeters session. So first, in terms of regulatory compliance for U.S. water systems, it is complex and difficult to achieve. But for these systems, as Ruth mentioned earlier, and the federal regulations for drinking water applies the same to all of Puerto Rico systems. So if you are a water system in San Juan or Plaza needs to comply with all the regulations, a small system of 250 or even 50 people have to comply with the same type of regulations. Just to give you an example of these challenges for these non-PRASA systems is that they are required to pay for certified laboratory analysis and reports that result in monthly and quarterly reports to the Department of Health, which is the primary agency. And along with the high electricity cost, this testing has become one of the heaviest burdens on this system. And some small water systems have to decide every month if they are going to pay for this laboratory analysis or buy chlorine for disinfection. The other challenge is the small operating and maintenance budget they have, which makes it difficult to cover the cost of pumping, testing, chemicals, and not to mention paying operators. In many communities, operators volunteer their time, and in some, no fees are collected. So imagine how they are going to operate or fix a leak on a pipe. As an example, a community of about 350 households charges $80 per year per household. You can make the math. That is not enough money to pay the operation. And the next challenge is options are limited when you live in rural areas, away from larger utilities. Piping costs for connecting these small systems can be prohibitive because of the rural locations they're at, so it's complicated. In rural areas, when there's a power outage or a storm comes, the roads are impassable sometimes for days. Some communities in these rural remote areas spend weeks without having not even communication with the rest of the world. And these systems are not connected to PRASA, and historically PRASA has talked about that it is not cost-effective investment and operation for PRASA, so they decide not to connect these systems. Another fact is that historically, these non-PRASA systems do not apply to the federal funds available through USDA or Drinking Water State Revolve funds, to give you an example. And this happens because they don't know the opportunities, they are not aware of them, and also because they lack the minimal technical, financial, and managerial capacities to qualify for this assistance or grants or whatever source of funds is available. Next slide, please. So the VersaWater partnership aims to connect communities to safer water solutions. We have initiated a project and installed a demonstration plant in Puerto Rico. In December of 2025, VersaWater successfully installed the first operational Agua Clara PF250 drinking water treatment demonstration plant and Plenitud in Las Marias, Puerto Rico. You can see Plenitud's location with their logo on the bottom left image. It's very close in relation to the non-PRASA systems. Plenitud is a non-profit educational farm and teaching center. It is dedicated to community service and sustainability. So this aligns very closely with our objectives, and they have become excellent partners in this effort. Now, please take a view at the map at the bottom left, as I just mentioned, which illustrated the location of Plenitud, and at the right, you're able to see the installation of the PF250 at Plenitud. So this is just a brief overview of our work. I will stay online available for any questions, and we're now handing it over to my colleagues who will explore these topics in greater detail. So thank you very much.
I will just let folks know too that Francisco will be with us to answer questions. We're gonna come back to all of the pilots and the demos and really break that down. But we're first going to just kind of back up for a second and talk a little bit more about who we are in the room right now too. And with that, I'm gonna hand it off to Ruth, who is my colleague from Cornell.
Okay, thank you, Tess. First, this is a pleasure. This is my first time coming to this conference, and I will be bringing my students next time. So I'm Ruth Richardson, and as Tess noted, I was the one who sort of grabbed this team together and put the right team together, and we became VersaWater. We started with a different name, and I'll talk a little bit later about our sort of process in terms of how we came to be VersaWater and the NSF program. But for now, I'm just going to kind of introduce me and introduce sort of what my journey towards this project was. So first, I want to just kind of give an intro to you. I think that there are some of you, I'm going to minimize him now, if that's okay. I know some people, but you might only know me from one of my areas. I'm kind of like a mallard. I do quite a bit of dabbling. That's a watershed joke. I thought maybe someone would get it, but that's okay. So these are sort of my more active areas right now. I have them generally grouped into sustainable water and wastewater treatment and biological hazards and biological water quality monitoring. So within the water and wastewater treatment area, I have a real interest in bioenergy and like energy positive wastewater treatment, including resource recovery and also blending different waste streams. I'm very interested in food waste co-digestion, for example, where it makes sense. And New York State is really interesting that way because we passed this law, the food scraps recovery law. So we need to find somewhere to put our non-edible food waste. I geek out on microbes. I'm an environmental microbiologist, nitrous oxide and methane cycling. We've had a long history at Cornell University of biogeochemistry, right? We've probably collaborated with many of you on that. And for a while, we had one in climate biogeochemistry that was focused on that. And I was the microbe person, and we had people at the global scale. The third bullet there, resilient water systems. So that's this Puerto Rico project. And I'll talk a lot more about that. And then I am currently the advisor for a project team, and I'm going to talk more about that, this Agua Clara Cornell. And I'll just briefly talk on the biological hazard side. I also have a grant from New York Sea grant that's active on the Great Lakes shores of New York. And I'm working together with people who are invasive species experts to make eDNA tool that is cross-management platform, so harmful algal blooms, aquatic invasive species, as well as fecal pollution, fecal source tracking, fecal source tracking for monitoring fecal pollution sources. I also bring that skill set, so molecular biology, environmental DNA, to proving that the technologies that we're working on are working, right? Documenting pathogen removal, like virus removal and bacterial removal is important for VersaWater. And then another area that's really interesting to me is harmful algal blooms. I'm particularly interested in really low buy-in. Like we have this microscope kit that's like a $35 microscope kit that you can literally take pictures, and we can then, you send them to us and we'll analyze them with image analysis software and predict back whether you're looking at a bloom and whether you're probably looking at a harmful algal bloom. Sorry, I'm using this as a chance to like talk about, because I feel like there's people in the room that might not even be as interested in VersaWater as some of these. So let me know. I'm just going to skip to the next one. So let me just focus in on the two areas that have really brought me to the point of finding this team. So I already mentioned Agua Clara. How many of you have heard of Agua Clara? I know some of you have. Okay, so Agua Clara, Cornell, the engineering college, the Duffield Engineering College, has like 35 project teams, engineering project teams. That's like there's over 1,000 students that are involved in these teams. Some of them are competition-based, like a steel bridge or a concrete canoe, but many of us are very open-ended, engagement-oriented, and Agua Clara is a major one of those. And you can see here, actually, that picture there on the stairs, that's the current student team. It's about 45 students right now. Now it's been 20 years. The co-PI, someone who's not here but works with Izumi, Monroe Weber Shirk, founded it while at Cornell. Now he's with Agua Clara Reach, the nonprofit. So it's over 20 years of the engineering, and the main emphasis there is small, repairable, operator-friendly water treatment, and students will work on different aspects of that. So the drinking water design since 2004, when it was founded, have actually, with partners that implement, there's now 100,000 people down mostly in Honduras that are drinking water daily from a, built in place, concrete, larger, mid-sized treatment plant. And I've been working on wastewater designs with those same guiding principles since about 2013. So about 13 years on that. So Agua Clara, really great tradition, really wonderful program of engaged learning, but mostly engineers, right? I also, though, right after Hurricane Maria, we got a grant from Engaged Cornell to investigate rebuilding or advise on and support rebuilding for water and energy. And I was focused on water there. So I had some projects. Plenitude has already been mentioned. I've been working with them for a number of years on things like rainwater harvesting systems and running workshops and installs of rainwater harvesting, as well as, you can see these pictures here, these little baggie tests. Has anybody ever seen these E. coli tests? They're like Ziploc bags with little compartments. They're like a most probable number test, but super crude. So it can give you some sense. You can see here, hopefully it'll work. You can see here, any of these little compartments that turn blue, that's a positive, just in normal light for E. coli. So this was a project we did, and we wound up, getting all these places around, not a lot. We were focused mostly here in the West, where we also had a GIS where we would inform that there were springs and surface waters monitored with these tests, and then the results are put out there so people can know. So the E. coli training, and then additionally, I was working with Surfrider. They have a Blue Water Task Force where they monitor beaches, but after Maria, they started to bring their skill set into also monitoring the springs. So we worked with them on that, as well as doing some of the microbial source tracking. When I was down there in multiple years, went down, brought students down for especially master's students, I got to meet some folks down there who were working with the water systems that ultimately became our collaborators. So, but I sort of recognized, I knew I'd been to Honduras, I'd seen the technology working. I said, we need to bring Agua Clara Tech into the US, right? And I think Puerto Rico really could benefit from it and be a great starting point. So with that, right, that recognition, so Agua Clara meets the US became VersaWater. I did want to say something about the Agua Clara ecosystem. So we have Agua Clara Cornell, right, and we're like university research, and there's some other universities that do other projects. We have Agua Clara Reach, who's one of our partners, right? But we don't do it all, right? We also have to work with the communities, right, either directly or indirectly, and as well as these implementation partners who know the location. In Puerto Rico, they better know Puerto Rico. In New York, they better know New York. In Honduras, or anywhere else, they better know that place. So it really is an ecosystem, and there's a number of plants, as I said, serving 100,000 people, over 100,000 people. And this is just, we'll talk more, you're going to see more about the tech, but this was an important one we did. This is Honduras, and this was a study we did. Again, this is powered by gravity, full water treatment. You could take 1,000 NTU water, theoretically. We don't recommend that for long periods of time, but it can treat that down to drinking water quality. And here we did E. coli measurements. And an important thing is during the rainy season, when the rains come, the water quality gets really bad in surface water. I mean, many of you know that, right? Some beaches even close after a rain because they know that E. coli is going to be through the roof. But anyway, so we were able to show that even in the rainy season, when the E. coli level is 1,000 per 100 mil, we always get it down below detection, which is what you want, less than 1. So I think that's all I'm going to say at this point before I hand it off. And then I'll talk more about the Convergence Accelerator that brought us together. Handing that off then to Izumi.
Thanks, Ruth. Okay, hey everyone, my name is Izumi Matsuda, and I'm happy to represent VersaWater as well as Agua Clara Reach, the nonprofit organization that is part of the collaborative. So Ruth already talked a bit about the origin story of Agua Clara Reach. So Dr. Monroe Weber Shirk, who's that second person from the left, he founded the Agua Clara program at Cornell in 2005. And this was really because he realized that too many, and so many people were realizing that too many rural and underserved communities didn't have, like they had failed or non-existent water treatment. And so their hypothesis was maybe it wasn't the community's fault. Maybe the technology just wasn't available that was a good fit for those communities. So from then on, they went to explore, what types of technological solutions could be created so that way these communities could have working systems. So the innovation and the implementation of these technologies, and Ruth alluded to this, is done like not only with us, but also with partners that are on the ground. And our main longstanding partner is Agua por el Pueblo, which is a Honduran nonprofit organization that does a lot of engineering work with us and continues implementing our technology to this day. So in 2017, Agua Clara Reach was founded as an independent nonprofit organization with the same continued mission, but really trying to focus on that implementation and that innovation. So today we still work with universities, as Ruth's little map showed, and one of our strongest partners today is still Cornell, where there's still a lot of continued research that goes on in innovation, as well as continuing to work with implementation partners, so that way when these technologies are implemented, it's actually kind of primed for success instead of dropping a technology and being hope that works out for them. And just to talk a little bit about the technology. So on the left here, we have this built-in-place Agua Clara plant, which includes some pieces just because the frame didn't fit everything. So that's concrete built in place. But that's really honestly economically restrictive for smaller communities, right? So one of the goals that Agua Clara Reach had that was kind of brought to fruition through this partnership with VersaWater was a technology that was based on the same physics as that original technology, but could be prefabricated and shipped out to communities and could be a little bit easier on the economic scale. So this is an example of the prefabricated Agua Clara filter. That's just a piece. It's not to scale, so it's way smaller than the built-in place plant, but we're really excited to be able to implement that. As Ruth mentioned, there's 26 built-in place plants serving communities. And this particular plant, it has a flow rate of 0.8 liters per second. And we're currently in the piloting stage for this tech. So how does, Agua Clara Reach overlap with the US and the US market and US communities? So Agua Clara Reach is a nonprofit that's based in New York. And although we currently serve communities outside of the US, we're really excited about the opportunity to move into the US and see what communities can be served by our tech and where we can collaborate together. So this expansion is currently in progress and is happening in partnership within the VersaWater Collective, and it wouldn't be possible without the funding from the U.S. National Science Foundation, which Ruth will talk more about later. So I'm really excited to learn from everyone how we could be useful in New York and what our work can look like in the future. And for now, I'll just pass it off to Tess to talk about ISC.
Yes, I won't belabor this point because a few people have heard from me already at this conference, but I'm here representing Syracuse University, where we have an Institute for Sustainability Engagement. So the Institute for Sustainability Engagement, among a lot of things that we do, one thing that we focus on is really being a hub for engaging communities in the work at Syracuse University, particularly our work in the environmental space. So we work to connect communities to environmental projects and resources and support their needs and goals. And particularly when we can make that connection between a resource at the university and a community need, that is where we really light up. those of you who have heard me speak before know that I'm really rooted in the Environmental Finance Center, which is housed at Syracuse University ISE. The Environmental Finance Center actually was founded back in 1993 to solve the how to pay problem of environmental protection and improvement. The EPA Office of Water funds environmental finance centers. Anyone familiar with EPA Office of Water here? Being regulated by it or otherwise? Okay. So the EPA, just a little history lesson, but back when some of these landmark pieces of legislation were passed, like the Safe Drinking Water Act, EPA recognized even back then that this was going to be a big leap and hard for communities to handle. They had to make a lot of investment. Funding was available, but isn't always available. Communities have a hard time accessing those funds. The environmental finance centers were really intended to provide that on-the-ground technical assistance to connect communities to those resources and funding so that they could provide safe drinking water in the manner that these landmark legislations required. So the EFCs are really here to help communities, and particularly in the water space, where we work for the most part is EPA Region 2. So that brings us to my good pal Francisco, who's minimized right now. But our team actually covers folks both in New York, and we have a Caribbean team based in Puerto Rico. When Francisco was talking to you about the challenges in Puerto Rico, those are challenges that we see all the time. The laboratory costs, we've spoken with communities that are sending out labs for $300 a week because we're testing for PFAS now. This is not, these are very shared core problems to small water systems that need to be integrated and need to be looked at in parallel. And the communities that we have both in New York and Puerto Rico do learn from each other when we can make that connection. So without further ado, that is really what brought me to Ruth. I think Ruth, we work a lot with Cornell, and Ruth was like, hey, how do you pay for water? And how does it make sense that when we're trying to do work with small water systems, it costs, how do they pay for it? And so we realized that paying for water, understanding how it's regulated, making sure that communities have what they need to take care of their water resources and to get all the money on the table was really part of the work that we needed to do with VersaWater. So with that, I'm going to pass it back to Ruth, who's going to talk about our convergence research with NSF.
Okay, I'm going to pick back up, and I'm going to, again, this kind of focus in on what is VersaWater sort of niche, where are we really focusing? And this is actually a slide that my colleague Monroe Webershirt put together just to sort of think about it. Some of these we've already talked about. So you have population size all the way down from a household level up to a mega city, right? So something like Tokyo. And then these are estimates he had of, that the distribution of the number of people in the world in those banks. But we've talked about this. Once you're a big enough town, it makes sense, a big enough system, have a large mechanized system. You're able to afford staff all the time, multiple staff to be operating it. You have a big enough base of revenue that you can save money for upkeep. So central governments are generally handling that. And then on the household level, depending on whether you're in the US and where you are or internationally, there might be a variety of things, including a well, right? Or there could be other sorts of disbursements. And then non-governmental organizations are often are focused at that level in terms of international development. And then these are the estimates of the number of communities. This is reinforcing the point that we have a lot of very small communities, a lot of people in small communities, and that's the gap, right? So when you move from it being like a individual, small, under the radar, not a small system yet, right? To being like 200 to 500 people, you're in this spot where you really don't have access. It's not the right solution for you to have very expensive, mechanized, highly staffed plants. So these are the small water systems. So we've been I've sort of alluded to technology that small systems need, but I kind of want to lay it out there. So ideally, no electricity required, right? Just to use Maria as an example, people in Puerto Rico didn't have water for 9 months, not because their system broke. It's because the power went out. Like water and energy, there's that we need to really be looking at that. So ideally, it could operate even during or even following a power outage, which are so common, right? That Bad Bunny sings a song about the apagón. That's the Puerto Rican word for power outage. A small footprint, right? That doesn't need a lot of land. High performing, in this case, we mean it can even treat surface water, which can be very high turbidity, can wind up looking after a storm like chocolate milk. Minimum moving parts, because moving parts fail, right? So you want to be thinking for repairability and repairability as locally as possible. So generic parts are another important piece. You'll see we use a lot of PVC. We use a lot of, water, drinking water certified PVC elements. And then the ease of use for the operator, right? So not incredibly complicated, not a lot of electronic kind of panels there, simple, very, very simple operation. So we then, and Izumi alluded to this, right? We now have this system, and we knew the Agua Clara, she talked about the large built-in-place concrete plants that, again, would produce very high-quality water, right? But now we need to get it down. And she mentioned the prefabrication, and that's been a big part of the VersaWater project is that shrinking it down, making it prefab. And as you saw with Francisco, actually now being able to fit it inside of a trailer. That's another big piece of it. So this is our very small community, these 250 to 750 people, where the prefab unit could be bundled, right? The base unit is 250. That's about 250 people's worth, but it's 18,000 gallons a day. Each of these units will make of drinking water quality. Now, of course, that's tech. The tech alone is not enough. I will stand by the tech. I think we all stand by the tech. I know the tech. I'm an engineer. I knew it wasn't enough especially what I was seeing in Puerto Rico. So actually, I'm gonna jump down here and then come back to it. So I saw this call, and I'll talk about the Convergence Accelerator program that has been supporting us. But I had to bring the team together. So on the left-hand side, I already had Cornell Engineering and Agua Clara Reach. So we are the sort of engineering team, the tech team. And I had met, there's folks that aren't in the room. This is out of the InterAmerican University of Puerto Rico. Our colleagues, Melitza and Graciela, they run a center that focuses on small community water systems. They do research, education, and conservation. They also do training of operators for running water systems. So they really know on the ground. What I didn't have was financial piece. And thankfully, is anybody here from Water Resources Institute? Don't necessarily recognize you all, but Brian, Ram, and Seth and the folks there, when I went and approached them, I said, I need people, I need to fill out this team. I was introduced to the folks at ISE, who definitely know the governance. They know financing opportunities. They do technical assistance on the ground. And luckily, they also knew Puerto Rico because it's in the region 2 for the EPA. So this was the team. And then has anybody heard of the Convergence Accelerator program before? Okay, a couple of you have. So the Convergence Accelerator is an NSF project, but unlike science-based, right, it's out of the Directorate for Innovation and Partnership. So it's the ones that run like the small business grants and things like that, trying to get tech to translate into society, right? And so it's focused on advancing the transition, right? It's not super basic as most NSF. It's the transition of that into real societal and economic impact. So, and the way I describe this program, it was like Shark Tank for academics, right? We really, it was wonderful learning. And the main sort of themes they have are Team science, you learn a lot actually, because it is intentionally bringing together multidisciplinary teams. Human-centered design, if we think of our customers, these small water systems, we needed to learn them. They give us a lot of skills and tools to be able to do that. Communication, storytelling, and pitching. We had to come up with a logo. So we are VersaWater, community water that weathers the storm. Isn't that cute? We wouldn't have come up with that without sort of some coaching. Doesn't mean it can't use work, but the communication, storytelling, pitching, and then because there were multiple teams involved, we also had these opportunities to share with other teams. Let me go back up here. So just to kind of give you a sense of where we've been and where we're going. So this Convergence Accelerator, again, it was a big program, and each year they were releasing a few themes, and then people could compete. So we competed in the theme that at the time was called Equitable Water Solutions. And we got our phase 1 grant. So there's 16 teams there to begin with. And then those 16 got a chance after 1 year of the planning piece, the planning grant, they could compete for phase 2. So we were fortunate enough to be chosen for phase 2. The track is now called Future Water Systems, for reasons you might guess. That happened this year or last year. And that one is where we are. We're just finishing up year 1 of that. So that's a $5 million investment in VersaWater. The idea is that is investment money, right? And then in phase 3, in parentheses, you're off on your own. You have you have revenue worked out. You have your business model worked out, right? You're out there. You're a business, a nonprofit, or a university center. So literally every Tuesday, we had 2 hours of curriculum. We had learning sessions. We had homework. So this is just kind of an example of the phase 1 curriculum that was out there. So the bottom line, let me see what's our time like, Tess? Okay. Cool. Sounds good. I'm going to just have another few minutes. So in the end, right, I'm skipping over some steps. What we really have come up with is this concept of a utility in a box. Okay, so we have the innovative technology, but with our whole team of VersaWater, we have expertise in funding access, capacity building in the community, and also sustainability planning for that community, right? So that they can manage for the long term. Because our success is not 1 year from now that's still operating. Our success is 15 years from now or 20 years from now, it's still operating. So then I wanted to just bring it back to a point that was made earlier. And that's this interesting, when you especially get to a very small community, you see this disconnect where, I'll use Puerto Rico as an example. This is a map here. So in blue are all the distribution lines from public water systems across the island. And in red are the sewer lines, right, for centralized sewer. So again, this is emphasizing there are many, many places where there is a central system, public system, but then the household does what it will with the wastewater. And usually they say septic of some sort. So in terms of our tech, for the drinking water side, these very small communities, the prefab unit, which we call our PF250, is going to be our marquee tech. And then for the wastewater side, we're recognizing that we're in this situation where there is the septic infrastructure of varying degrees of performance, but we're going to use that, and instead of replacing that, we've been looking at these pre-treatment reactors and of the type upflow anaerobic sludge blanket reactor. It's not a very nice word. That's why we go with UASB, or I'm starting to workshop names for it. I'm calling it the burpee among our team, because it essentially burps your wastewater. It removes a lot. Ooh, this one we already went through. Ooh, sorry, it burps your water on the way to your septic. Okay, so it removes a lot of the particles, and I'll talk a little bit more about the tech later on. But this just gives, and when we're dealing with small systems, right, the wastewater piece often isn't thought of when we're thinking about the drinking water piece, and we're trying to do that and see it as a holistic. And then we wind up seeing this interesting hybrid of centralized drinking, decentralized waste. And this is kind of some of the stuff that we had to do for the Convergence Accelerator. We had to look at our competitor matrix and all that. And we are, our sweet spot is here. And there are some other players in this very small community range. They tend to be either temporary, right? Or only can treat groundwater, right? Can't treat surface water. And I can't remember the third thing that they are not. But the PF series that we have fits right in there for full-time operation. All right, and we'll talk a little bit about this later on in Izumi's section. So as I said, in phase 3, they want you to be your own self-sustaining. So our own sustainability is an important part of it. And this is just a graphic that we use. So we have our 4 main partners here. This is Syracuse, the InterAmerican University of Puerto Rico, Cornell, and Agua Clara Reach, right? And the idea is that we have a variety of inputs and resources, including impact investors, including federal funds that we understand the sort of the rules for. And then in terms of impact, another important thing that, they challenge us to be aggressive, right? So we are hoping, and then the next decade, to become a household name in the US wash sector and direct over $20 million to fund small systems throughout the US. So getting that $22 million of investment, right? A reminder, a dollar spent, all right, is $4 in healthcare saved, right? That benefit. So when we put it in financial terms, the team is looking to have $94 million and that's just in the economics within 10 years. So an ambitious plan, and we are going to be looking for partners, especially as we move into the mainland of the US. So I think that's the end of my slides there. All right, thank you.
Yes. Okay, so just for context, this phase 2 for us, for our team specifically, started in July of 2025. So we're kind of like wrapping up the first year of phase 2, which is 3 years long. And so I just wanted to touch on a few things that we've worked on and accomplished throughout these past almost 12 months. So Francisco talked about this a little bit, but there is now, since December 2025, a demonstration plant in Puerto Rico at this eco-educational farm called Plenitude, who's a great partner of ours. So the PF250 is there, and just so you know, it's used for demonstration purposes only. So there's no community members drinking this water, and that is, for a few reasons. This is used as like an outreach, marketing, training tool, and we really want to make sure that this tech is ready for human consumption before we kind of like implement it in a community. So this was kind of one of the steps to showcase it within the context of future communities. And so there's already been leaders from 6 potential communities that have visited, because the goal is to have this tech implemented within communities so that way they can look at it, ask questions, see it with their eyes. And there's also hopefully like regulators that will visit as well and participate in technical discussions about water quality challenges, etc. So we've also engaged an engineering firm who will be working on permitting, compliance, and also kind of environmental resilience of this entire setup. So that way, when a water treatment plant is set up, it will be able to survive hurricanes and whatnot. So that's going to be happening over the next few months, and we'll also learn a lot from it to implement for our community systems. There's also another thing we're really excited about is the Cornell demonstration plant that's actually completely finished fabricating. So it's going to be sent to New York towards the end of this month. So that way throughout the summer, we can work on it, we can visit it together, and there can be more local US people, like US mainland people, that can visit and view it and ask questions. So another thing that's pretty important is that a pilot study is required for innovative technologies in the US. So that is something that can happen at Cornell. We can obtain data and we can really be ready to prove that our technology works as well as we think it does. And then a little bit about some kind of like technical innovations that we've had. And I won't spend too much time on this, but I did want to touch on it because we've been doing that in parallel with our pilot work. So originally, we kind of considered the technology to be, you know, existing in a permanent structure, but Ruth had the great idea of taking the plant and throwing it into a trailer so that way it can be more mobile. So we did that for this pilot, and you can see it in here. There's actually, I'll talk more about this later, but there's a filter out here that will fit into, the new version will fit into the trailer. So everything can kind of be contained and movable. And one of the reasons we're excited about this is that it gives opportunity for emergency response systems as well. So that way, you know, you don't have like a permanent structure that only is there for a few months. Yeah, another good thing that we were thinking about is if this allows for communities to kind of test out the technology before they agree to it full time. So if for some reason it doesn't work out with the community, then it can be moved to a community where it would actually support them instead of kind of sitting there as an abandoned technology, because that's something that we've been trying to avoid happening. I just mentioned this, but as you can see, I don't know how to work the pointer, but there is the filter kind of excavated. So the original.
Red dot on.
Okay. It's okay. Oh, do I have to hold it down?
Yeah.
Yeah. All right. So here's the filter. So the rest of the processes are in here. And then you can see this pipe connecting out to the filter. And in order to like make this filter work, it had to be excavated. There's now like a tarp, so that way it's not affected by the rains and also the beating sun. And there's also a platform that's been built to access it. And honestly, it took a lot of time, a lot of logistics, and it was pretty expensive to do that. So then it became kind of Agua Clara's initiative to redesign the filter. And so here, I'll use the pointer again, but here is kind of the upgraded filter, and it can sit on the same slab as the other processes. So we're really excited about that because it's way more climate resilient and it's way more movable in that case as well. It's faster, it's more cost effective. So that's something that we worked on. And then something that we've had to adapt for is US regulations. So we've been mostly working in Central America where things are a little more lax, but there's, you know, the National Sanitation Foundation has requirements for any materials that come in contact with drinking water. So we've had to kind of like swap out a bunch of our materials for things that are approved. And that is unfortunately more expensive, but we do need it to be approved in order to implement it in a community. So that's something that we've been working on. And the first version of this that is like fully compliant for US standards, it will be implemented at the Cornell treatment plant. So we're really excited to see it there. And something that I don't want to forget to mention is the automated chemical dosing system. So the goal right now for our technology, an operator has to be there a lot of the time to kind of like manage the chemical dosing. But that's a lot of resources required in order to keep the operator there. So in order to lower that and also to kind of make it more efficient, we are developing an automated chemical dosing system that will hopefully be in place by the time we finally have a plant in a community. And this system will do a few things. It will measure and track plant flow rate. It will measure chemical flow rate and filter water level, so that way it can notify an operator when backwash is needed. And it will, it'll just save a lot of time, a lot of money in the long run. So we're really excited about that because small communities specifically with their, you know, as Tess mentioned earlier, there's just not a lot of resources in these small communities. So they don't have the resources that like a large town or city might have to hire a full-time operator. So this will lower that burden specifically for small communities. And now I'm going to pass it to Ruth to give some updates on the UASB before we pass it back to
Yeah,
Tess.
I'll be very quick about it. But I do want to mention this because this is a little bit of a recruiting. So I wanted to sort of mention this. This is the predecessor, this beast is about 8.5 feet tall, and it's got, your wastewater comes in at the top here. There actually was a tipping bucket. If you look in the top, there's a little bucket that will, once a gallon fills, it dumps it and it doses it down the side arm where it comes up and it inverts, goes upflow. What's not shown here are these beds. The bed is full of these granules of bacteria that make methane out of organic material. So the wastewater comes up through this bed of bacteria. They're making gas. The gas is collected off the top. The water, which is partially treated, comes out this effluent pipe. And it needs polishing before it's done because there's still nitrogen, there's still phosphorus, there's still a good number of fecal coliforms. We don't get that much removal. It could go into a septic tank. That's our plan down there. It could be in a trickling filter. It could be an activated sludge tank, something to get rid of those additional contaminants that doesn't remove. But the fact that it removes solids and organic material and produces biogas, so this is us monitoring. We had this implemented for about 16 months of time at the Ithaca wastewater plant, treating pure sewage, just coming right in. We siphoned some off. And this is an example. We wound up getting about 30 liters. This is just a household unit, about 30 liters of biogas a day produced. And this, so again, this was our behemoth. And now, but now that we're at the household level, there is a natural dosing. So we don't need a sort of doser to kind of give small doses coming in. So we've shortened it a little bit. And well, we've taken off this tipping bucket. So anyway, we now have about a 5.5 foot version. This is me. I'm literally taking my work home with me. I have a septic system. We're going to try it out in my house. It's a little awkward, but we're going to do it. My students will be studying my own sewage. And this is me packing it, actually, this is even the biggest one, the bigger one, you know, outside that tipping bucket just fits here in this little hatchback. So, so I am very interested. I had some slides earlier. If let me go back up if you don't mind, I'm sorry. It's trouble. Because I had my contact up here, this version of the slide. So we are looking for volunteers. We have more, we made more of these. We fabricated more of the small ones. If you are interested and willing, and you're interested in the biogas, right? That's a big piece here. You either will love that idea or you hate that idea. If you hate that idea, maybe not. Yeah.
You're talking 30
of biogas, yeah.
Okay, that doesn't seem to me to be the turbid usable.
Sure, it's about, that's 20 minutes of a burner a day, of a single burner. Yeah, it does not going to replace all your energy needs.
Yeah.
Good point.
Not a lot of BTU.
Sure. Over a week, though, you fill a mattress and you can have a party in your backyard with one of those cute little fire pits. It sure can if you have the means to compress it. Yeah. Otherwise, wow, this sounds like you're in this business. Yeah, and then I'm handing it off to you. The tipping bucket is optional. It's to avoid preferential flow. Like if we just have it kind of trickling in all the time. Comes from the household. Yeah. Yeah, just like it essentially gets put in place between your house and the septic. Oh, sorry. This is on the wastewater side. Sorry about that. We're jumping now to wastewater. Yeah. I'm not suggesting we're treating that. We're not closing the circle. That's in the future. Yeah. Correct. Unless you have a pump that's like a sump pump kind of thing that can pump it up and let it drop. Yeah. Correct. The smaller unit can also fit in a utility room. And I'd be glad to talk to you about all of the things we're doing for sensing to make sure that that's safe. I'd love to talk to you later, but let's move on yeah. Am I in the right test? Help me out here. I'm handing it off to you. I don't know where I am anymore. I can do it.
Sort of separate very well. From the black water, would that be?
It's even better, that's a great point. Black water is even better. So the more concentrated the water, the better this is an
I
option.
can imagine you have your washing machine or you've got a family worth of showers and you flush
Yeah.
out the system in no time.
Absolutely. So in fact, and this is something we learned in Puerto Rico, we were talking about, I was talking about black water with folks there, and they're like, what do you mean, what is black water? And I described it, and he said, oh, that's wastewater. Often they'll take their gray water and use it for other purposes.
right.
They just plumb the
we
toilet
don't.
and the bathroom. We don't.
Right.
But we show it works on normal domestic wastewater with like the Ithaca plant. I mean, that's pretty typical domestic mixed waste.
But it's already mixed. At the household scale, it would come either as
True.
mostly gray
Yep.
water or,
Yep.
you know.
We rely on particles being captured in there. So even if it's like a pulse of particles coming in, they slowly grade in there.
All right, so we are coming to the end of the presentation-y part of this. And we're at the part where we're going to talk a little bit about what we are looking forward to doing here in New York. First thing that I want to call out is that we do not want you to leave this room and then never talk to us again. So please, this is our website. We just launched this in March of 2026. Right now, it just has kind of some of the information similar up to some of the tech and what we're looking at here today. But if you QR code this, you can get to the website. There's a contact us form. We're in an active stage of really looking to engage people and improve the things we're working on. So the more feedback we get, the better. That's kind of how this program works. It's use-inspired research. So check out the website. We've already heard about the demo plant, but we're hoping to do a ribbon cutting, which everybody's invited to. That's going to be hopefully this summer, maybe in July. Plant tours coming in the fall at Cornell in Ithaca, New York. And then, question mark, can we do some New York community pilots? So we're looking to see if it might be possible for, maybe after we demonstrate in Ithaca and we are fully approved for use in a community, if there is a community that would like to partner with us under the auspices of this lovely program and NSF support, to see if it makes sense, to see if it works for them. And if it doesn't, that's great information for us to know. And so that's both for the PF 250, and Ruth has already made her request for folks to maybe reach out about wastewater as well. So we're entering a phase of learning and piloting in New York, and we want to work with all of you. Lastly, just to bring it home, like our why, the reason we're doing this is because there are 2 million people in the US without water right now. We want to see solutions that are a little bit cheaper, a little bit easier to use, and a little bit better. And we want to see that 4.3 return on investment for this work where we see that benefit to society. So if we could get a little, if anybody here is interested in learning more or wants to talk to us about it, we want to see how we can scale this in New York. So with that, we do want to go back to Mentimeter. You guys might be a little tired after this. I want to pause for questions. Just see if there's anybody else has anything top of the mind. You want to talk to anything you just heard, but we will make you work after this. Okay, great. Yeah, in the front here.
Your presentation, thank you. So for the New York State pilot, are you using surface water as a source?
Yes, that would be what we want to do.
We could use groundwater, but it doesn't show off the tech. We need dirty water to show off tech essentially, and surface water tends to get much turbid.
So I know residents around the lake near us who are using untreated lake water unofficially at their camps, and there seem to be quite a few of them in upstate New York all over. But the Department of Health says that you're using, surface water, which is not like approved or, permitted. So how does that whole legal side work?
I don't know that I know that legal side. I know in Cayuga is also a problem because the habs there, people are drawing water. They're not supposed to be drawing water. So I don't know, maybe someone else in the room knows that space better. But
Yeah.
No, you do.
It's sick.
Huh?
There's no problem until it gets sick.
Yeah, so I consult for the pro bono for the Lake Association, and that's Otsego Lake in near Cooperstown.
Yeah.
We started to have HABs. It's oleotropic, but still gets HABs. And we literally got blamed that the lake water is not drinkable anymore because of the toxins. And I was like, what do you mean? And it turned out that people have been drawing the untreated water, and they do have some sort of household filtration and even UV, but cyanotoxins are not removed. And then they were complaining to the Lake Association that, you know, their source of drinking water is now gone. And I was thinking of those situations where your system could work.
Yeah, you need to get a number of those people together to decide to put the system in though, right? That's.
In the back there.
So for the pilot program, I understand that you guys want to do this and you're working in Puerto Rico. I wonder, are you open to the idea of doing this in the Dominican Republic as well?
Oh.
Yeah, I mean, I'll say the NSF wants us, at least in phase 2, like it's a US, like we should be focused in the US, but in phase 3, that's an active conversation in the team. And obviously Agua Clara Reach has done a lot of international work, so, yeah. Thanks, short answer, yeah. That's very, yeah.
That's because we like,
Sure.
one of my families from there, and a lot of them have cited they provide surface water. So, it would be done something good.
Yeah, I think there's a lot of a shared, I mean, Francisco's minimized, but there's a Caribbean reality to water. Let me bring him back. Okay. Francisco's here now, but we would love to see this kind of as this is intended to work in Caribbean environments, so ultimately it would be great to see it kind of succeed across the Caribbean.
Yeah, like we have a plan in progress in St. Vincent and the Grenadines, so we think that like these contexts are very applicable for that.
Yeah. Saw a few other hands. Did they go down? More questions? Okay, back to work. So we will maybe let you go. We'll do one question and then we'll let you go a little early because it is a 2-hour session. We did not decide that it was going to be a 2-hour session, but it is a 2-hour session. So if I can pull you back to Mentimeter just for 5 minutes. I want to ask you all a question. There we go. Okay. So the biggest thing that we'd really like to learn together and take insight from all of you, especially moving forward, we can talk more about kind of where we could fit in to your communities and your lives. I'm somewhat familiar with some of the lake intake systems that are from the 70s that have been there for a little while and now people are not supposed to have them. So I'm a little familiar with that. We want to know how we can better support small systems in New York State. This goes beyond just implementing this one technology. This group really came together because we wanted to help figure out this challenge and because we feel like the right people are here in New York to do it. New York has a confluence of all of these challenges. We're sort of like between New York and Puerto Rico. It has some of the most difficult water treatment conditions in the continental US. There's more that goes into that too, including a legacy of contamination, but we want to think about that with all of you. Can I pick on anyone to kind of talk through what was put in here? Contact highway superintendent. That's a very specific and doable thing. Who put that? Can you expand on that?
There,
Yeah.
inherent in those providing advice as he goes. So I would not speak for him by any means, but he is whatever resources are out there, he's learning as he learns.
That really resonates with me because we sometimes talk about how in small communities, there's the people wear every hat. And what you just said was about that was like 4 jobs in one. So, and we see that in our work too. We're cognizant that when you want to go into a small community, there's usually 1 or 2 champions that are doing everything, keeping things alive, working. Yes.
I ended up around that fee, so I didn't answer the question correctly. That was back to the one we started with. But anyhow, I wrote the other one, to museums like the Wild Center and the Adirondacks.
Yeah.
They involve all sorts of sustainability issues, and the septic systems especially, and access to clean water are really a challenge in rural communities like that, and where it's so important to preserve the natural systems and not let, the septic systems be prevented, right?
Right.
The challenge, not just Lake George. And so partnering and doing workshops, would be a great place.
Yeah. And maybe theoretically, there's more surface water. There's more ponds up there there's quite a lot of water up there to work with. I love that idea of maybe kind of having some installation in the Adirondacks that we could use to learn.
Yeah, very brown water, we heard that too.
Yes.
Very brown water.
Very brown water. Yeah.
I do want to maybe, because I've a couple of things, even with the direct intake for people, I think one thing that has been interesting is you think people want it. But a lot of communities say, well, fine, we're fine, we don't need this. Communities that have like $80,000 worth of fines from the federal government because they're not managing it. They say, I drink this water, my grandparents drink this water, and I can get bottled water. And then we say to them, your bottled water, it's gotta cost you money. And then one interesting thing is people say, well, SNAP benefits paid for my bottle. And you're like, well, so we can't apply any SNAP benefits to paying for your water bill, to paying your small water system. But through SNAP benefits and food, we're encouraging people to drink bottled water. So it becomes this like messy problem is like, how do you, until someone gets sick, right? Someone got sick from HAPS, then there's motivation. But like the motivation is not automatic. You look from the outside and try to understand it.
Mm-hmm.
So that's something that's very community specific. So, I'm wondering if people have experiences. How did you motivate people in New York to care about an issue? Might not be drinking water, but countered that.
Yeah.
It's support one with layered complexity, so you're not continually adding to what the learning curve is, but you're supporting them through it and you help them see what the benefit is. They're much more interested in what you're partnering. What if what you're doing is adding regulation after regulation, and there's some money to help. There's not time or energy for that.
Yeah.
Great point.
A lot of our communities in New York they've reached the end of their rope in terms of how far their infrastructure can go, and it is being replaced. And so we're working with communities that are taking on more debt than they ever had because they have to and they don't have a choice. But it makes it very serious, when you're asking ratepayers to pay more and this infrastructure has aged. Some communities are already doing it. When we continue to cross these bridges, we're talking a little bit about surface water. If some communities are using surface water and they can have access to potentially a lower cost portable treatment unit, maybe it's cheaper. We're hoping it's cheaper. It does make it, in the context of you've already spent all this money, a hard ask, but an important ask, because there could be the money that you spend now usually saves you money in the future. A lot of folks are realizing that if we'd done this a few years ago and raised our rates incrementally, maybe it wouldn't hurt as much as it hurts right now.
How could this work if a small municipal water system that is using groundwater has a citation for surface water intrusion or contamination?
Oh.
I know of a small community near me, and I actually got a letter, although I use groundwater.
It sounds like it's a system that is
Under the,
groundwater under the influence of surface water. It's that weird kind of thing. Yeah,
Yeah.
you do have to do treatment rule. It has to follow this surface treatment rule. Minimum of filtration. Full chlorination.
Yeah, well, apparently they do not have the resources to
yeah,
do that, so.
yeah,
Exactly the problem we're trying to work on.
yeah. Well, this system in theory could be better aligned to if you're going to be managing that anyway, this system might be easier for that particular community to manage. At this point, it sounds like there's some adaptation already maybe underway. But that is kind of a circumstance that this system would be intended to support. Potentially with the use of like a pump. We do see a lot of pumping now with solar panels. Solar panels have made it maybe not up all the way in some of our cloudier parts of the state, but those are some ways to make, when you do need a pump and you have to pump groundwater to make that electricity free, you can sometimes use solar. Okay. Okay.
What extent do you think that the health department's regulatory bodies have an appetite to allow the installation of a UASB, and do you think it like fits into the domestic wastewater guidance as like a advanced pre-treatment, or do you think it fits in the existing framework?
Well, with us embracing the septic infrastructure and on the ground, it would be like a pre-treatment, and it would work with that existing system. Were there more to the question?
Yeah, just I know sometimes that regulatory agencies are a little very
Right,
focused on a very specific lane, and this would be a anaerobic digestion component of.
And when you get into wastewater, there's very different people who are there. Even if it's still the Department of Health, there might be some different people size of the community. So we have been focused heavily on our drinking water and the regulations, and those are extremely tricky. We are the wastewater is sort of the following behind, so we're not as far along on knowing what that landscape is. But EFC also, I'm going to be calling on their expertise because
we're
different for wastewater. What it is in your purview.
We have to look at the local health laws. We have to get back into local health laws and see if there's any kind of like local ordinances that would support more pre-treatment or that kind of.
Just to be clear, there's nothing added. It's not like we even add any chemical, like in the drinking water, we add coagulant to make sure the part. But in the wastewater, there's nothing artificial extra added, so it's just really a natural system.
Like aerobic pre-treatment or a PMOS biofilter.
Yeah.
Yeah.
So the new unit operate.
So I do want to give this is a 2-hour session, and that is pretty impressive for folks that already did a whole day conference. So congratulations to all of you for taking on all of this learning. We're going to keep these results and look at them. There's a flyer up here in case you guys would like to learn more. And I'm going to give you these 5-6 minutes back. I don't think the organizers will be mad that we didn't use all 2 hours. And come talk to us more if you're interested. Thank you so much for joining us. Thank you, Francisco.
Thank you.
Hi, guys.
Yeah, right. And I didn't introduce this in the
Alright, so.
John?
So what's
But thank you.
So,
See if.
what- I mean, if you put this, what does that get you?
What does it get us?
I mean, because
It seems like you're into this and you're a skeptic
No, I'm
and
not.
and that's great. I just,
I'm
but
not in the business at all. But, you know, you're pre-treating something that's going into a septic tank and basically, you don't, mostly. I mean, 99% of people don't. What are you supposed to do? Probably every 3 or 4 years you pump it out and send it to a municipal wastewater treatment plant. And then the remains inoculated for the next process. So,
the solid, the main, the septic itself, the main thing is that there's fewer solids entering into septic. Right, 80 to 90% removal of total solids.
okay.
That's the main benefit to the septic.
Okay.
And that can either just be fewer pump outs when needed, or if you're the kind that doesn't pump out, less clogging, right? Less risk of overloading, if there's clogging in your system.
But then you have to clean out your device.
You jump, so there's for every 10 grams of solids destroyed,
Right.
90% goes to gas, only 10% residual gas. And then we just have a drain where the part of it is the bacteria, the excess bacteria drain on a sideline. You would have to deal with that, but if you have a septic there, you can send those right at, you could just
Yeah.
rejoin with that waste stream.
But I mean, isn't that what the septic tank does? I mean, isn't it meant to destroy the solids and convert it into soluble material and gases?
Do it very well, though. That's why the solids build up. The other benefit, and this is gonna be the make it or break it, is
Okay.
you want biogas now. The
Yeah, well,
place in, yeah.
30 liters a day isn't gonna get you very far.
But if you,
Look at it's a mole. It's a mole of methane. I mean, you know, it's like, what can you do with a mole of methane other than vent it into the atmosphere? So now you're not, now do you qualify as an EPA source? But under the Clean Air Act, you know.
Point out that you're
Skeptical of everything. So it's like that, I mean, I'm.
You're proving the point. It's not for you. You.
No,
it's
I
not
know.
Well, let me just describe you, and this is not your situation, but this plenitude, oh, yeah.
But I don't understand why reducing solids in this thing and then having to clean it out is any different than reducing solids in a septic tank and having to clean it out. I don't see where you're just transferring the process. You're not, you're not doing anything.
Finding it right.
No,
You're not calling it a septic hauler.
Well,
Calling it a septic hauler as often.
well,
Again, it's a 10% solids residual. Every 10 grams of solids converted, only 1 gram of the
okay,
bacteria drain off.
okay.
So it gets, instead of 90% removal, it's only 90 times 0.9, so 81% removal.
Okay.
Your next one. Solid induction.
But I'm isn't that what a septic tank does? Doesn't it remove solids as well?
Well.
Well, then design a better septic tank.
What's that anybody septic tank?
Why did?
And they're right. So I'm John. I teach at SU. So I really enjoy it. I want to ask where is water?
Yeah, I so.
Yeah, I said that.
Okay.
Try to work together on some methane stuff.
I was
Some methane,
Yeah. I mean, he's relatively new.
Thank you.
Yeah. Yeah. Great, yeah.
Really
When you were kind of going through your research.
Yeah, we're natural, so we are talking about water. Great, and what's your name?
So I'm environmental engineering. I do some, I'm actually a teacher, so I don't do much research. But I'm sort of some theory. A lot of, some, a lot of like.
It's like a nice compliment.
So I was around here in Uganda for a while.
Water.
We were like building. So, yeah.
Until there's the right.
I don't think there's a lot of reason. But yeah, just. Do that.
Yeah, and then there's Tom.
Yeah, Tom.
And.
Yeah, so he's technically retired now.
Okay.
He's still.
Thanks for introducing your place. I'm familiar, but. Hi, good.
Nice for.
Thank you. So our session.
So we are working with and we're still gonna try to.
From Carson.
Okay, so I was wondering, like for the graduate students who are about to graduate, is there an opportunity or a platform for us to start for the next step? Like as a volunteer, or be the part of, anyway.
Yeah, we certainly, I mean, we don't have like a free postdoc position. We kind of got our hiring done, but, definitely, I mean, why don't we, are you here at, you're at Clarkson, and are you?
I'm in some box, so I'm going to get the postdoc or any job, facility or any volunteer work I'm with, because I just want to. I'm working on I have multiple projects on sustainability for detecting E. coli as well, one of them. So that's kind of aligned with your work, you know? So I'm really interested in the like,
Yeah, so why don't, let's make a connection for sure.
I think it'd be great.
Yeah.
I'm certain about the time.
You know what? I'm not really on LinkedIn. I don't know why. I guess I should. I always thought I say that with like people looking for jobs, and I'm not, but hey.
that's the thing, and then the right people.
Yeah. Yeah. So what are your interests in
Enjoying water quality, I know for from the drinking water, like I'm working on getting the E. coli in the drinking water or the surface water. So like my research is to design something that should be simple, affordable,
Oh, okay.
and sustainable to test the water quality using the smart patches.
Oh, is that where you were poster?
Yes, I did.
Okay,
post
great.
this,
That's cool.
yeah, and that is like AI based.
I was really interested in that. Yeah, you have the pads and then
Yes, we have a patches, we have the mobile apps that work.
that's great. Yeah.
So with the continuing research into that field, your work is quite interesting. I really like it.
Wonderful.
So if we can get a chance in future, you know, you might get some vacancy or some space, you know, please remember me, you know, I'm really interested.
Yeah, I mean, I assume that your interest, the work you're presenting on here, you're trying to keep advancing it.
Yes.
Yeah. I mean, we could certainly talk about once our plant is up and running, like we could be testing, we're gonna be doing like regular E. coli tests and molecular biological testing. So like qPCR based,
Yes.
especially for viruses, because those are not gonna grow viruses. But that would be maybe an opportunity to test out your tools.
And I love to learn.
Yeah.
Like, you know.
Yeah. Yeah, I'm curious with the tools that you're developing, where do you imagine is the audience of using it? So the reason I'm asking this is
Yeah, I think
a few years ago, we had we did testing with a handheld quantitative PCR machine. You could bring it into the field and do it, and it worked great. And we were really interested in it, and we worked with like state beaches, because it could be rapid testing.
Yes.
the main challenge was like, anybody who uses regulatory action
Yeah.
can't rely on a tool that hasn't been approved by the EPA.
Yeah.
And so I don't know if you've started to think about like how, so we call our things screenings, you know, it's not a test, it's a screen. Or yeah.
Actually, I keep the same things in mind. Think about the people who actually need it the most. It should be like simple for everybody to use. Any screening method that should be affordable and sustainable, the main reason. Like if we are using that test, it could be, if you are disposing it, it should be safe for the environment, you know,
Yeah.
as well. It should not create waste to the economy.
Right.
So keeping these things in mind, we actually design a smart tattoos, 3D printed. We can say that smart tattoos or felt that you can actually work by dipping and scanning it, you know.
Ah,
So how it works, it actually changes color based on the E. coli counts present in the water.
yeah.
Right, and then actually that is works on the enzymatic cascade color reaction. So we have a whole chemistry developed already, and then I transform all these things into our smart patches. And the best thing is we design a mobile application. We have a guy in our group that is working on the AI and machine learning. And for precise color quantification, we customize the mobile app that can actually capture the events and give you the counts of the E. coli right on your phone.
Mhm.
So this project is very nice. This is one of my projects. I have like multiple.
Very cool.
And this is going to publish soon. So your work quite aligned with mine. I read that you, I will read more.
Mhm, mhm.
And that's why I'm really impressed with, you know.
Yeah, very cool.
Yes.
Yeah, it seemed like I looked over the poster,
Oh, you
and the
did?
little, yeah, I saw, or I was looking through the videos and I saw your name and I was like, put that one on the list. And then I didn't get to it, but I thought it was pretty cool. Yeah. Yeah.
But yeah, but it's hard to find the research that aligns with you when you are moving forward for the graduate students. You know? Most of them switch, you know, but it's, I'm open to learn to your field, what you guys are doing, what's great, you know.
Mhm.
So yeah.
Great. Okay. Why don't I don't do LinkedIn so much, but I can certainly give you,
The search.
yeah, and then,
Yeah.
Here is our little website, everything, yeah. Well, I'm getting that in my email also. Yeah. R.
During summer.
So honest, we had R Carly on our panel yesterday.
Yeah,
R. R. E. R.
Said she was.
CORNULL. Thank you so much for reminding me of stuff. Please don't forget.
Okay. Helps me to see it when I hear it. Oh, of course, you can keep that, yeah.
It's nice to talk to you.
Okay,
Yeah, I'm looking forward to it.
sounds good.
I hope you will keep in mind.
Okay,
Yeah.
you'll have to come down to Cornell sometime. It's not far.
Yes.
Yeah.
That care about water, so.
Agreed. Yeah, I know, so I mean, Connor he's doing a lot of other stuff this summer. That's available, but
Like the party.
got a few hours, so something. And then Riley is technically her funding doesn't start until July.
You know, my always forgot, but right here.
So we can definitely do something.
Even with this project, you will see the pilot too, if it happens to be close. I would love for the students to like put that.
So the hot sauce packet.
There's a pattern, if they'll still like water, maybe the health ones like around to it.
Yeah.
Yeah.
I don't know, yeah, it's a big question as to the direction the whole EWB thing is gonna go next year, right?
Have we told you about our EWB woes?
No.
Okay, so we don't have a EWB chapter officially in Syracuse. And some
Really concentrate.
very incredible students have been trying to do it. Yeah. And the chapter is ghosting them. Not the chapter, but the national EWB has just been ghosting them. Like,
What's your name?
Yeah, I mean, our understanding is like with all the funding issues, the government, everything, their funding, I guess, is limited. And so they're not like, what they've told us is they're not accepting new chapters right now. So we've just been sitting in this limbo for like a year.
Oh, wow.
really a bummer. So we've been trying,
And that is one that's very top down in terms of projects, right? They're like, you will work on this is
Seems like it.
contract and.
Yeah.
Yeah, I mean, there's a chapter at Cornell
Yeah.
and it's like compared to some of the other ones that are open-ended, it's not, it's pretty prescriptive.
Well, Susan has been advising this club.
Oh, she has.
Yes,
Yeah.
so Susan went to Cornell.
Yep.
And then did Agua Clara. So Ruth taught Susan and then we took Susan. And just the cycle repeats. The time at Agua Clara, I think it's like the best.
As if we wanted to hold them there forever.
Like Agua Clara is more like vampire, like they bite. And then they infect other people in a good,
yeah.
in a good way.
In a good way.
But yeah, so we're trying to.
It's, it is a very, like, the spirit among students.
Yeah. I mean, it seems like a huge group in that photo.
Yeah, I mean,
Yeah.
it's been bigger than that, that's, but yeah, yeah, it's a nice shot to that. Moving off there. Yeah.
Anyway, yeah.
All right, well, yeah, thank you.
Thank you so much, John.
Yep.
Appreciate
Yeah.
it.
I have a weird question about ESF, so I have a niece at ESF. Are you able to take, are you able to take class at the other university?
Yeah, it's very,
How was
very
it?
important. Yeah,
Okay.
so,
Perfect.
Great.
for example.
Everything was great.
I had complete faith in you guys.